Welcome to DevOps Accents, a podcast on everything around DevOps, public cloud, and cloud-native topics, with your hosts, Pablo, Leo, and Kirill.
Okay, hello everyone. Welcome to 11th episode of DevOps Accents. This is a podcast where we talk everything around DevOps and cloud-native technology, and I welcome everyone. And thank you for joining us today, those who are listening to us and those who are watching us, I don't know, on YouTube. Can you see us? Of course you can, because we have a thumbnail on top of that. But anyway, I encourage you to give us subscribe and likes right away. And last time, during our 10th episode, we talked a lot about open source and the way companies use open source to make money, among other things. And for those who missed that episode, I recommend listening to it first and then come back to this one. By the way, the best way to not miss anything at all is to be signed up for our regular bi-weekly MemCadev newsletter. MemCadev Dispatch is where we compile the most interesting articles and videos we published for you and whispers in with our thoughts and deliver to you every 2 weeks. And also we have a referral program that allows you to get cool t-shirts and mugs with your own portrait. So go to the description and subscribe today. But anyway, the reason why you want to listen to the 10th episode first is because today I would like us to delve into a topic that's been a matter of much debate in the industry, is the compatibility of open source technology and cybersecurity. This is something that I briefly touched last time, but today I want to discuss this in detail. So we discussed how open source technologies affect the way we develop, distribute, and use software, basically, I don't know how to put it, democratizing innovation and stimulating a global community of developers. Yet I still do not entirely understand how, with the increased adoption and reliance on these technologies, we can handle cybersecurity. Can openness and security even coexist? So what do you think, guys? I mean, I know it's like maybe a difficult topic to discuss on a broad manner, but there is a saying like that based on Linus's law, like given enough eyeballs, all bugs are shallow. Does it hold true in the context of cybersecurity? Like from your experience, how does the transparency of open source software influence its security?
There's this famous thing about Linux and Windows, is that they always say that there are no viruses on Linux, and there are always lots of them on Windows. And one of the reasons is that Linux is open source, and there is like way more visibility and control over what's happening. So, like if everything is happening in open, it's a bit harder to kind of add some malware, even though it's not like guaranteed. There are also other things inside Linux that just are built in a way that prevent things like viruses in general. But one of the reasons I said is that Linux is open source.
But even talking about this thing about the viruses, I only can remember one antivirus in Linux, this Clan IV.
Right.
So it's the only one that I remember. I cannot ever think in another antivirus in Linux. What does not mean that there is no virus as a definition in Linux, because there is no sense to think that there is no virus or even that there is no way to attack. But yes, you're right in this point.
Yeah, but Linux is like a tool and is a software that is extremely widely used. And of course, a lot of people would like to contribute not only to its convenience but its security. But when it comes to smaller tools, the tools that are dedicated to some particular cases, like when we work with cloud and that gain access to our code infrastructure, there are so basically when we use cloud, open source, we expose our own infrastructure. And does it mean that we expose all vulnerabilities to potential attackers if we use open source because they know how it works from inside, by what means it connects to your infrastructure, and then they can use it and just get access to inside of your code?
I think you have two sides here. Of course, that if I show you all the map of my house, for sure that you can go and you can know where are my weakness. You know where are my windows, you know where is everything, and then you can attack my house. This is one of the sizes, and of course that yes, this could be something like taking like okay, I know that because I took this code, and imagine these days with all these AI tools that you can take all the code and not using this GPT or BAR or whatever others AI tools, because they are not going to give you where are the problems, but you can generate your own AI tool, and then you can say, okay, this is the Git repo, study this repo, and give me all the backdoors, all the security problems, everything that you found here, because I want to attack that. You can do that for sure. So, because you have everything. And if you are the bad guy, you are not going to tell to the good guys where are the problems, because you want to get benefit of that, for sure. But you need to think that at the end, in the other side, the people who expose the code, at the end, the good side is that you have hundreds of people working, and many people can find the issues. So this is the other side. And then you have CVEs, you have all these security, let's call tickets, where it's telling that there is a problem here, and every product that is related to this one, know that there is an issue about that. So day by day, the security is something that is more working in common. So for sure that a closed environment, like imagine, not every part of Microsoft, because some parts are open right now, but okay, imagine some closed part of Microsoft that you don't know what is this code doing, more or less, for sure that can be attacked. So it does not mean that because the code is closed, nobody can find a bug. It's in the other way around. So you can find bugs everywhere. So, but the thing is that who find bugs? I know that there is a bug here. Now, what do you want to do? Do you want to explode that because you want to get benefit? Economical, because you are a bad guy. Let's call a cracker or something like that, or a bad hacker. Or you are a good guy and you want to tell, okay, there is a problem here. I'm going to make a pull request. I found this issue. So please change this part of code in all the application in the planet Earth that are using this application, because there is a way to attack you. And there are hundreds of cases in the history where one person found a problem and then he disclosed the problem, and everyone fixed the problem.
So the problem is you never know when the issue was originally found. So if you take this,
Sadly,
like what was this huge issue 2 years ago, 3 years ago, the Spectre, when they found out that basically every processor more or less is vulnerable to certain caching attack because all this architecture works in the same way. So you could basically hack any device which is running Intel process, and then also AMD was using the similar technique. You know, there was like lots of buzz around it when this vulnerability was discovered, but it's been around for like a decade or maybe more than a decade, and we will never know how was it exploited till it became public. And same goes for this last year or 2 years ago with Log4j problem, that allows you to basically remote execute code on any Java application that uses Log4j for logging, and that's like every Java application more or less. And we also don't know like for how long this issue existed and how it was exploited. Because imagine you're find this issue, one option is that what Pablo said, you go and you say like, yes, I found this problem, here is the fix, or like, there's actually a very complex process how you should report about such things. But another option is that you could just use this vulnerability for your own profit secretly and whatever, use Log4j issue to steal some sensitive data and, I don't know, buy some stocks based on this data, for example, or do other crazy things.
Yeah, because you need to differentiate, for example, what happened if you found an issue in, I don't know, whatever repo that nobody used, or at least it's only used by 30 people, and it has only 3 developers. Nothing happened. But what happened if you have a problem? For example, like these 0 days, that is these kind of attacks that you can take absolutely control of everything. And I remember that there were 0 days in many companies, like for example, LinkedIn, Facebook, all these kind of companies. So, and they don't disclose the code. So the code is, is closed. But most of the companies use open source code. Okay, I can say that every company use some part of open source code. And even I can tell that maybe this open source code is most reviewed than any other code in the world. But the problem is not the guy who made this open source code. The problem is one Pablo in the world, one Peter or one whatever, who goes to imagine Facebook or LinkedIn or whatever company or Google, and he started to code, and he made a little part of code that maybe is exposed. Nobody take care of that, and at the end you made the biggest backdoor ever in the world. So and then you read every day, guys. So yesterday I was watching a podcast about a guy who 19 years old in Spain, and he is the most famous hacker in Spain. He was in all these policy databases, in all these Minister of Justice databases, in all the companies databases, one by one after the other. Okay, because these days it's super simple to be a bad guy if you don't care to be in prison, for sure. Because you only need to go to these webs, you get the exploit, and you through the exploit, and if the exploit is working, okay, if not, I will go to the second exploit, because at the end, I'm going to scan all your ports, and I'm going to find a vulnerability that, as Kirill was telling before, who knows that this vulnerability is there. If it's only the bad guys, then I can exploit the vulnerability, try to attack you in this way, and then I am inside, and then I can get the info.
I remember, Leo, like when I told you that at any given moment, dozens of people try to hack our website, you were surprised.
Yeah.
That if you actually check the logs, you can see that all the time someone tries to hit particular URLs on mkdev.me, like .me/wp admin, so this WordPress admin interface, because they know that there is like 70% of all websites are WordPress, and then not all of them are up to date, and then there's a list of vulnerabilities in WordPress. So you can actually just go one website after the other and try to hack them, because they most likely website uses WordPress, and you can just access it and steal the data or do something else with it.
Yeah, and for for most of them, the logging for admin account is admin, so you don't have even to figure a new login.
It sounds like I thought I used to think that it's stupid, all these script kiddies who just scan the internet for like ports and the particular path. But then after I saw so many cases when, like, there was this problem with the MongoDB when someone discovers that there are like thousands of MongoDB clusters completely unsecured, not just admin password, but they just unsecured completely and exposed to the internet. All the AWS S3 buckets that have like completely public access because someone was too lazy, was not aware that they should actually secure S3 buckets. So this scanning actually works. It's like, it's happening, and these evil people still do this kind of port scans and URL scans because it's actually working. It's possible to get some websites hacked like this.
And even famous case is this one with the cameras. As you know, Google, you can search for the type of camera, Google or whatever others search, you can go to Vine or whatever, and you find for a type of camera, and you can see hundreds of cameras that most of them open, as Kirill says, and you can go directly. So the other day, I was reading that there is in this parking, this new parking that where I live in the island where I live in, is super common. This kind of parking now that you go with the car, you read the plate of the car, and when you go in and when you go out, you only need to you pay, but you don't need to introduce the ticket anymore. So it's not that you need to introduce the ticket, so automatically read the plate, and then the fence go up, and then you leave the parking. And those I was reading in one place that they're always using one kind of brand, always, at least where I live in Spain, and that all of those they have a ISO, they have a back, and you can connect with Bluetooth to all of them. And I was not believing that. And the other day with my wife, we went to the car. Then I was with the laptop. And really, you can connect and you can see everything. So you can open and close the door if you want. So this kind of security of themes I think is more dangerous than the internal security of the open source that is reviewed by expert and even created by expert. Because the problem is that I am not going to talk about the case of an atomic nuclear central, something like that, because I have to imagine that this is not connected to internet. But imagine whatever factory, because it's super cool when you read these magazines about security and hacking. Always there are two kinds of security, the hacking of software and then the hacking of hardware. And this is super interesting because it's talking about hacking of things that you use daily. Like, for example, time ago, there was a guy who went to an airplane and he tried to prove that he was able to control the I don't remember the model of the airplane, because the thing is next. Normally, when you go to the airplane and you can plug an USB, the ideal scenario is that you have a computer for this USB and you have another computer to control the airplane, because you know that there is something like a little data center inside every airplane. So then the problem is that the guy that plugged the USB, he was proving that he was able to control the airplane. So because through this USB was able to connect to the computer and was able to take control of the airplane, and was able to turn the airplane. So what I mean is that this kind of security is the most unsecure, the most scary to me. And we were talking about electric cars the other day. So, and the software of these cars, this is really scary. And this thing, all of us will go with our cell phone. And you see how beautiful is the sticker? The kind of stickers. So this is really scary because you go with that every day. And they know where you are, and they know what you are talking. And your laptop, they have a camera. These kind of things for me are more scary than an open source that is, checked by thousands of people monthly.
Yeah, but if we get back to more or less your everyday practice with open source software, one thing is vulnerabilities inside this software, but other thing that is interested me in, is the fact that you use some particular open source creates a vulnerability to your infrastructure. For example, if you use, I don't know, like Terraform or Kubernetes, open source part of Kubernetes. So, for example, a hacker knows that you are using Kubernetes, and he knows how Kubernetes works. And basically, this gives him the idea of your infrastructure setup or something like that, and he can use this very fact against you. Is that the case in your everyday work, or there are? So I mean, should you create some security layer on top of security measures that are already implemented in Kubernetes?
Oh, yes, because there are like not that many. But it doesn't have anything to do with open source or not, right? So regardless of if you use an open source, you still write your own software that you sell to your customers, and all of this needs to be secured. So it doesn't matter if it's about open source tool or about your own software or about some cloud provider, you should still perform the same measures to protect your endpoints, to protect the traffic inside, to do the threat detection. So when someone is inside Kubernetes cluster, for example, you should get an alert that something suspicious is happening, which could be done with some.
Yeah, so there is a layer between Kubernetes clusters and all other part of your code that prevents an attacker to go between these clusters or something
You
like
need to
that.
look at this in depth because Kubernetes is not a security platform. It's a tool to run containers. It's an orchestrator. So it does not, it has, for example, API of Kubernetes has this role-based access control, and it uses like encryption for the traffic between you and the API. All on top of this is your job to secure the cluster. So you need to figure out like how do you get notified when someone managed to get inside of one of your containers and tries to execute some script. So you should prevent the possibility of someone running the scripts inside your containers. And if someone figured out the way to do this, you should get notified, for instance. So it will happen, not because of Kubernetes, for example, just because you misconfigured Kubernetes. Because it's an open source tool, there are many ways to use it. You can build the whole platform on it. It's super flexible, which means there are many ways that it can become insecure. And same goes for practically every software, including your own software. So it could be that you're using Java and there is this issue with Log4j, but it could be that your API or HTTP endpoints just do not process requests properly and they allow SQL injections. And that's also like, you need to think about this case. So it cannot be just about let's wrap open source tools with actual layer of security because the enemy is everywhere, not only on open source level. But
And even sorry,
no,
sorry.
but clearly, if there's like if you're using some particular open source tool and there is a vulnerability reported, then you are at risk and you should update. But you need to always evaluate if this vulnerability actually is applicable to you. For example, when you use some open source tool, you're not using one open source tool. If you use Kubernetes, you actually use like probably hundreds, if not thousands, of different like libraries in Golang, because in the end it's not just one code base; it connects to many other code bases. And vulnerability in each of these code bases could mean that you're in danger. And what Pablo said, like these reports about vulnerabilities, they're more or less open, so everyone can just find that, okay, this Python library of version 237 has the issue that if someone inserts emoji, then your whole application just falls apart. But it could be that in your case it's not important because you only use this library as a dependency for some other library and it's only used inside some internal tool and there's actually no way in your particular case that emoji will be inserted. So in the end, it's not like you should not care, but it's not your highest priority to fix this. So at any given moment, all of your libraries have some kind of vulnerability, either like a minor one or a big one. And it's the job of infrastructure team, of security team. Ideally, like they work together to identify these kind of things and work on fixing them.
And even you need to think something. These days, imagine, I don't know, whatever Postgres, whatever application that you use, they are super happy that the biggest customers tells that they are using their own application. So, for example, you have MongoDB and you go to MongoDB page, they are going to tell you we are using MongoDB. If you go to LinkedIn and you check the CV of one person who is working in the company X, he is telling using Mongo, blah blah, blah Kubernetes, AWS. So the people who is working in the companies, they are telling to you what products are used in the company. So because
Yes.
they are telling what are the products. So, but even the company says proud to be partners of this company. So at the end, everyone is telling what they are doing because you cannot close this door because mostly everyone, you know that mostly everyone is at some point he's using Apache. You know that. You know that mostly everyone at some point he's using one database. So SQL kind of database and non-SQL that kind of database. You know that 99% of the people is using Linux. You know that you take the most common pieces, and at the end, you know that most of the people is using the most common pieces. And I don't know what is the biggest problem, because if you find an issue in one of the most common pieces, for sure that you can attack most of the places. But if you find an issue in one of the most uncommon issues, the good thing is that nobody, maybe because there are some kind of application that nobody is going to update, because this is one of the other problems. Maybe the version 2.1 there is a huge issue, but you need to update to the version 2.3 or 2.4 or 5 or 6, 7, and maybe you have something that you never updated in the last 5 years or 10 years, and because it's working, and then for sure that you have a problem. So what I mean is that today everyone knows what others are using. And the problem is not in that. The problem is that every company try to have updates always of everything, but everything is related to everything. For example, if you want to use Kubernetes and you want to have an storage over Kubernetes, normally you use CSI, but maybe imagine there is another company like Cisco, like NetApp, like whatever the company who's creating another product, and maybe there is a problem in Kubernetes, but there is no problem in this other hardware companies, but the problem here in Kubernetes is affecting this one. So, and in the other way around. So it's so complex that you cannot close things. In most of the cases, the security in the companies is, oh my virgin, please, nothing happened here. So because you close your eyes and you says, so there are so many combinations, so many amount of things that you say, come on, please don't attack me, don't attack me, don't attack me. That's all. It's the only thing that you can do.
There are no challenges that we couldn't overcome. Whether it is immediate infrastructure problems or planning a future project, we won't simply answer your questions. We become a part of your team to help you complete the mission. Our solutions consider the interests of your business and the combined expertise of the industry, as our staff is made up of more than a dozen experts in different areas who share decades of field-tested experience and knowledge with you.
You guys specifically make it sound so scary and complicated, or because from my perspective, this is like a really complex problem, and I assume each company should track all the security issues, potential vulnerabilities on each part of their work. And who is that guy who does this? Because I imagine you not only have to understand how cybersecurity works and to what issues you are exposed with the code and what problems may happen, but you at the same time you have to understand everything that you to do in your everyday work. Like you have to understand cloud, you have to understand in AWS, Azure, Google Cloud, to be able to track all the vulnerabilities and understand how they affect your code and your company. So who are these superheroes who can do all of this? Because this sounds super complicated.
There is no like one person, because so in the DevOps world, there's even the term DevSecOps when security is a bit more involved, because traditionally security comes like at the very last stage or when things are already deployed, for example. Now, an ideal scenario, you work together with security people in your company to prevent things from happening. Or like, for example, if there's a new feature being built, you should also have someone with a bit more knowledge in security to actually like do some analysis if you're doing something stupid in terms of security. Like if you're exposing some administrative endpoint to the whole world. But it's actually a big issue, because I was reading the other day that there's like for every sounds like for every 40 developers and 10 infrastructure people, there is only one IT security professional in the company. So some like proportion like this. So it's just not enough. And they, as you say, it's impossible to be involved in all of this. So part of this responsibility falls on the infrastructure platform engineers, because for sure it's also part of the job. Like Pablo and I, for example, we're not cybersecurity specialists, but we know many things related to security that are around cloud infrastructure, for example, because it's part of the job. And I think that's how companies should treat it, is that it is part of the job, not only of someone for whom it's a full-time job, but also of platform engineers, of system administrators, of developers. And it should be part of the software development lifecycle as well. So you should have security scans in your CI/CD pipeline. You should have some continuous scans on the infrastructure. Try to prevent from bad misconfigurations from happening. Because it's not just that there is this vulnerability in some open source software. There are like hundreds of many other ways that you can be vulnerable to an attack. It just could be like with open source software. So what happened with Terraform 3 weeks ago, I think, is that one particular version of Terraform, 1.2.2 or something like this. When you try to, like, HashiCorp figured that there was a mismatch in the hash of the package. So when they published the versions of Terraform, they also attach the hash. So they basically calculate some string for this package, and you can look at the string, verify your local binary, and if they match, then you are sure that this package came from HashiCorp. Because it could be that you download Terraform, and then someone between you and HashiCorp just gave you exploited version of Terraform, and you're just using this version of Terraform, thinking it's usual Terraform, but it actually just secretly leaks the data to third parties. And there is no issue with open source tool. The open source tool doesn't have this vulnerability. Mm-hmm. It's just that someone tricked you to download these malicious versions of Terraform. And that's what happened, I think, some weeks ago, that HashiCorp was publishing, I think, Code Climate, the CI/CD company. They were first to figure this out, that they got notifications that the hash does not match for this particular Terraform version. So it's like, like HashiCorp says it should be ABC, and your local system says it's like DEF. You're like, fuck, so that means my Terraform version is not the real one. Like, what? And could be it's been like this for like 1 year that you were using this broken Terraform version. And why? Because you could actually prevent this from happening, because when you install software, you should also verify this MD5 or these hashes of the software. That's what also Linux is doing. When you try to install the package, there's like a separate configuration that it checks upstream also for these hashes. But if you just download something from some package from internet, there is no this verification. So like another way how people
and
can
it's crazy how fucking smart is the people, really, to do bad things. Because how the people is able to trick and to track and to find a little bug to say, okay, I'm going to do that. And maybe they are not going to get any economical benefit. Maybe they are not going to attack. They are not spies like in the movies. They only want to do that because they enjoy doing that. So it's like yesterday in this podcast, I was telling one guy when they were asking, how do you feel with 18 years old at 1 o'clock in the morning? You are at home while your mother is sleeping in the other room, that you are in the database of the national police in Spain with all the people there. And the guy was telling, I was feeling like God. Yes, but the problem is that 3 weeks later, he was arrested, no? So, and he needs to be in prison. So this is maybe the main problem, because most of the people think like, wow, the adrenaline, no? It's like, this is crazy. And talking about one other problem about this, how to fix the problems, because one of the things that are used most is containers. And the containers are working with layers. So you, for example, you have your container, and you always have something, it's a first sentence called from. And in this from, you are telling what is the previous image where your containers is starting. So imagine that you have an onion, you have different layers. So I'm going to start in this layer, and I'm going to add my new layer on top of the previous layers. The problem is you can say, okay, I'm going to update my container, and my container is only updating my layer, but you are not updating all others that you have down. And this is happening in many places, because the problem is that when you update yours, You need to update the previous one. You need to update the previous and the previous and the previous, and sometimes it's 2, 3, 4, 5.
Yeah, exactly. I even wanted to ask about a lot of dependencies when it comes to creating something like this. Like when something happens in one place, it pulls all other things, and who knows what will happen in the other place of the code.
Yes, and many times when you do these updates, what is happening is that the code is not working. And this is the problem, because you have something in this level, version 3, and previously the base was the version 2 or something else, imagine operating system, but then you jump, and when you jump, there is a new library, or there is a new functionality, or there is something that your code is not considering. And then as soon as you update all the previous layer, when you attach your new version, it's not working. And this is a problem. And this is happening because all these pipelines that update the images mostly never update the base images. Only update the code that you have, but it's not updating the front. And if this front is updated, maybe the previous front is not updated either. And if this is updated, maybe the previous is not updated. So it's a cascade of updates that you need to do that at the end ended in that I can tell you. It's different, for example, when you work for a company who is working with money. When you work with a bank or things like that, everything is security. So you cannot move a finger without security in the middle. But when you're working in whatever other company that is not working with money directly, it's different. Security is not normally the priority number one.
It's actually a good example, right? Because we used to bitch about banks like being very slow to innovate, because there's like, and then if you see like quite often there are some financial companies like there is this bank in Germany, N26. They used to be built on top of Wirecard, which collapsed, but it's not important for this. And they were really like, they appeared as this very modern digital bank. They were building lots of new features in first years, and then they got a banking license of their own, so they became a bank, and they didn't need this Wirecard as this banking backend. And if you look at the amount of features and new things they release afterwards, it's crazy. It's like 2-3 times less. I think for 2 years, I just didn't see anything new happening. Because now, when you have a banking license, you have to comply with so many regulations that it's really hard to do things. But that's also example of like what happens when you actually like take security as serious as possible. Like you put a stick in your wheels and you cannot move.
Yeah.
Yes, and I wanted to like briefly touch what basically these people do not in financial companies, not in fintech, but in regular companies. So the guys and the people who are responsible for their security, do they run tests or some applications like those who are from quality assurance? Do they have their own tools that check whether your application, whether all the parts of it are secure enough, and how do they communicate and interact with developers on everyday basis?
These days, you have scams for everything. As soon as you have you want to download, depends of the place. Again, there are companies where you said, I want to install that, you go to internet to download, that's all, I use that. And then let's see what happens. But there are companies, more secure companies, where when you want to download something, like a band that we were working time ago, so where you wanted to download something, you need to request permissions to download something. So, and if you want to get this image, you need to request permission to get this image. And it was even easy for us to even create our own image rather than to download the image. So at the end, everything depends. And then when this image appears, they do a scan. But we need to remember something. The companies scan about the errors that they know. So, and this is the problem. You are only going to scan about the CVEs, the security issues, that you know that are in a database, an international database known by everyone. So, but if there is an issue that is not known, for sure that is not going to be scanned. There are another applications that they can check your code and check if they can find a vulnerability. For sure, you can do these kind of scans too. So, and it's going to tell you If you have, for example, here a buffer overflow, you have something like that here, and then you can try to remediate these issues. But this is different kind of scam because this is related to your code. So, but the code from third-party companies that you add and those codes are not open source. For example, you cannot scan. You need to trust in this company.
Yes.
There is another set of tools that I find really exciting, this threat detection, especially for Kubernetes and these containers. It's basically the idea of, there are like a mix of open source and the paid products in this space, is you install something on your Kubernetes cluster, and then it starts initial scan, so it looks at what your applications are running. So it says then your Ruby application runs like bundle exec rels to start the server, and normally no other commands. So it builds a baseline of what's your applications executing, and then you can say like log this baseline. So whenever there is any malicious process that tries to run whatever else, it will just block it, which I think is pretty cool, as long as this tool itself doesn't have vulnerability. But there are many layers, like there are many scans. There is like this tool, for example, called Checkov, which allows you to validate your infrastructure as code for not vulnerabilities, but for misconfiguration. So it seems like you try to create database with a public internet access, then it will tell you in your pipeline, like no, it's not okay. Just don't create this kind of database. You should fix it.
But
That's a cool.
Sorry, in the same way you have
Yeah.
applications that are doing the other side. So you have many applications that you can find backdoors, you can find the security issues. So you have apps where you can imagine you're here and you see this IP, this public IP, and it's exposing whatever number of ports, and then you do a map of these ports, and then you know if this is filtered or not filtered by the firewall, and after that you start to execute whatever kind of attack, because there are many ways to know what application is behind in the other side of the port, and then you start to do thousands of attacks to this one. Because what I mean is that in the same way that, let's call the good guys, I don't know why, but okay, they try to execute this kind of application to find the problems and try to fix those problems. In the other side, the bad guys, let's call it this way, they try to do the other way. They try to find the errors and try to attack. So at the end, you can do an experiment. You can get one IP in AWS, Google Cloud, Azure, public IP, and just post publicly a VM, EC2, Compatibility, whatever. And you check the logs. In 10 minutes, you start to have thousands of logs. You just post an Apache, and it's crazy. Boom, 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 every second. Because there are people, there are bots doing that daily. Try to find what do you have to try to, and only because of pleasure or because there are bad guys or whatever thing. Because, for example, today, how do you know, Leo, that you don't have anything in your laptop that is, for example, controlling your camera? Or how do you know that nobody is tracking you in your cell phone? How do you know that nobody is doing that to you?
Well, I absolutely don't. But at the same time, I have like these tools, like disable something, but I don't know if it even disables it. Because, okay, so there is a famous picture of AI tool in Snapchat where you ask Snapchat if, do you know where am I? And Snapchat answers, no, I don't have access to your current location. But then you ask it, where's the closest McDonald's? And it gives you direction to the McDonald's on your street. And the closest McDonald's to you is here. But how do you know that if you don't have access to my location? And it's, yeah, I'm sorry, I don't know where you are. I'm sorry, yeah, I don't know where's the closest McDonald's. So yeah, even if I have all these tracks disabled, I still not sure if I'm not being tracked.
It's like a social contract, right? Because it's not really what we discussed with the cybersecurity. It's more like you make a agreement with whatever, with the Apple, with iPhones, with Google, with Android. It's like, yeah, I told you not to track, and then you will not track. So that's like, let's just agree. It's
and you need to believe.
Yes, there is no hacking involved. It's like, yes, this company told you that it will not track. if you trust it, okay.
Yes, I trust you. Because it's
this is
impossible not track today, because what you need to do is you need to remove the headers, you don't want to track. So it's in the other way around. So it's because it's so simple to track these days, whatever application, that at the end, if you don't want to track, you need to do it the other way around. So it's even some cases more complicated to remove this thing that to do the track. But the point is, the security is not something based only in one point. The security is based, and the open source security is not worse at all than the non-open security. At the end is the same. So the problem is not what are the known problems. The problem is what are the unknown problems, and this is the real problem.
I remember we've been discussing with Kirill why we use some particular tools and not the others. And the answer that he gave to me that I liked is that, for example, when we use Dropbox, and we can be sure that what we store there is secured. And if it's not, there is a company that we can sue if something goes wrong, for example. But it's not the case with open source. Yeah, so, for example, if I trust my data to some open source tools, like, for example, this cost optimization tool that you, Kirill, described the other day on the article named "Can you automate cloud tests?" The tool is, I believe, InfraCost, and it's open source. And from my understanding, it has access to a lot of things inside of my infrastructure. It gathers information about what resources do I use and at what capacity and how much I pay for them. And it can even adjust the amounts that I spend on a certain part of my infrastructure. And I trust this sensitive data to this open source tool. But if something goes wrong, who I can complain to for...
In InfraCost, like the feature of InfraCost is that it does not look at your actual infrastructure, it looks at your infrastructure as code. So if you have like Terraform code which creates like 5 EC2 instances, it will calculate how much it will cost per month. And then it will maybe will recommend to do something about it. The thing is that you need to trust that it does not send information about what it discovered your infrastructure as code somewhere else and then resell it, for example. Because in the end, it's a really cool tool, very easy to use. So it's actually like it takes you 5 minutes to install it for all of your infrastructure as code repositories and get these cost reports. But, then you need to think about where this data is going. I actually don't think that they do anything bad or anything at all with this data. But again, just because I trust these guys.
Yeah, but from a manager perspective, like when I allow my developers team to use certain tools, I still need to think how this data is used. And I also I wanted to ask the thing about it, Kirill, about this cost optimization tool from a manager's perspective. Does it allow me to not only track but configure it without a deeper understanding of infrastructure and how it works, to prevent my company to spend a lot of money on that, or it's still a tool for developers rather than managers?
In case of InfraCost, I think it's a nice small utility to give you a rough estimate. But if you actually need some proper cost analysis, cost prediction, reports, you need to look for this in your cloud provider. So AWS has Cost Explorer, which recently was re-optimized to be especially manager-friendly and less human-friendly. Well, it became increasingly hard to quickly filter through costs, but you could generate very good Excel spreadsheets out of it easy. So, and before it was like you could quickly click around the UI to get all the cost information. So that's where is your actual cost and your cost prediction. You get like per hour metrics of how much you spend. And infra cost, I like the tool, but I'm always hesitant to introduce it anywhere because it ignores, well, doesn't ignore it, just it's hard to give you a cost estimate just based on your infrastructure as code. It works for static infrastructure with like RDS clusters or database instances, the compute instances. But if you have some serverless solution, it can actually help you. If you have an S3 bucket for storing files where you pay per file and per API request, a tool like InfraCost can actually help you. It doesn't know about your use case. For example, for MKDev, we use AWS Lambda for background job processing in our Rails application. And the amount of jobs depends on how much traffic we get, because we process requests to collect some simple analytics. So InfraCost has no way to actually know how many requests we get per day if we have a spike or anything like this, because its nature is static. I think they were working on some feature to pull information from from APIs like this Cost Explorer on AWS, but I didn't really check how far they got. And I think in the end, the source of truth will be on the cloud provider side, and a tool like InfraCost is just something nice you can plug into your CI/CD pipeline. So when you open the pull request, you see some nice numbers, just as a ballpark estimate of what will happen.
And getting back to managers and the estimation of costs, it's because the infrastructure is so flexible and scalable, and it's how you pay depends on how you use it. Meaning that if you have a lot of users simultaneously connected to your application and use and overuse it, so your spendings will increase. And there are tools that allow you to track these spendings in real time, and then generate the plan for the future spendings based on these graphics. But is there a way to to make these costs not depending on the usage, but to be more fixed? Because for manager, it's a nightmare to think that one day something happens with the application and it go viral on some TikTok, and then he wakes up seeing that his bill increased 10 times, and just because the developers set infrastructure that way.
I think what you describe is one of the biggest obstacles for some companies to migrate to the cloud, because they need to change their thinking from budgeting or fixed budgeting for a quarter in advance, because they know, okay, this quarter we need to buy 10 servers and cable them, and that's it, to move to this dynamic nature of the cloud. And you can, in AWS, commit to particular, also in Google, in any cloud, doesn't matter. You can commit to particular usage. You can say, I want to spend 20K per month, and then you get a discount. But if you use more resources, more infrastructure than is covered by 20K, you will still pay extra. That's like Datadog, for example. They are famous for there was actually there was recently a story about Datadog and Coinbase, because apparently Coinbase, they had so much money in 2021 that they committed to Datadog $65 million of usage.
Every year, right?
Yes, so they say
only using Datadog.
They said basically, we want to spend 65 million per year on Datadog. Here is the contract signed. Okay, doesn't matter if it's usage or not. They committed to this usage. And then, once you sign this contract, you can do anything. What if you don't like Datadog, and what in 3 months you realize you actually only you need 100 times less monitoring capacity from Datadog that is covered by such contract. So yes, it gives a peace of mind to manager to sign something like this, but you still need to pay extra if you overuse, and if you underuse, you'll just feel stupid because you overpaid. So it's just managers in this case need to change the mental model that it's pay as you go. You pay for every little thing as it happens, and that's just the way the cloud is. You should try to optimize in any case. You should be a bit aware of what you're paying for, but in the end, it's the cloud. It's elastic by nature, including costs.
But the cloud is like when you go to the casino. At the end, there is always one winner. That is
Oh no, Pablo,
is the
don't
house.
tell that.
No, but true, it's the house. So what I mean is that is made in the way, is making the way that always the cloud providers are going to win. So because as Kirill is telling, you can say, okay, I'm going to book 30K this month because I want to use this money for that. But at the end, if you don't spend this money, it's money that you already paid. So, but if you, and even it's a, because for, imagine, AWS, these 30K, they can cost to them 20K. So they have, imagine, a profit of 50%. But if you don't have this book in advance, maybe you pay not 30, you pay 40K. So then the profit that you have is 100%. So it's not these numbers. But what I try to explain is that always they are going to sell you something with a discount, but always with a profit on top. So what I mean is that if you, imagine that you want to buy clothes, and then you pay 300 euros every month to a company, and then you can go to a company. You can go to Mango, to Zara, to whatever, and you can buy clothes. And then the problem is, what happens is you 1 month you are sick and you cannot go out of your house, but you already paid 300. So then the company gets the 300 because this is our deal. And the next month you spend 250. Okay, the company is safe another 50, but the next month you spend 500. Okay, if you spend the 500, you're going to pay 200 more on top of the 300, and you will need to pay that.
But there should be tools, and I assume there are such tools that allows you to optimize your costs on infrastructure. Because if you take, for example, how you spend electricity in your house, you may turn on lights on every room, expecting that at some point someone will enter this room and they need for the room to be lit. But instead of doing that, you turn a light only when you enter this room, and you turn the light off when you leave the room, thus optimizing your costs on electricity. And after that, each month, the energy company calculates how many electricity you spend in total. So I assume there are tools in infrastructure that allows me to deactivate some, application or to power them so that they don't spend AWS or Google Cloud resources for me, and helping me not to spend extra money on that I'm not using right now. Is that the case?
Yeah, there is even like some solutions from AWS that they offer. There are like lots of software as a service that do it. There is like some open source tools that basically the standard case is that what we always recommend to our clients as well is that if you have some dev or staging environment that is only needed during the workday, just stop it for the night and for the weekend, and then you save, I think, like 46, or like maybe even like Pablo is better with math than me, but it's so like let's say 50%. Like you cut your cloud cost in these environments by half, just because every day is like 24
Crazy.
hours, so 8 hours it's going to be stopped, even more because the workday is like 8 to 10 hours. So that's 14 hours of savings per day plus 48 on the weekend. Lots of savings if you just stop them. And it's not so hard because cloud infrastructure is API driven, and writing, even without any extra tools, you could just write some Python script to do it in like a few hours and get the savings.
And then again, this is an open source solution that still gets us back to the idea that you guys need to understand what tools you are using, how you protect yourself from your data leakage, and how you optimize your spendings and whatnot. So even though today Pablo and Kirill basically proved to me that open source solution in most cases are more secure, you still have to pay a lot of attention. But anyway, thank you everyone who've been listening to us today, who joined us. I hope you liked it and that you learned something new today. If you have further questions about it, on how to tweak your open source, or maybe questions about cost optimizations, that's a very deep topic. Don't hesitate to write us and just ask us directly by replying on your bi-weekly MKDev Dispatch newsletter. Give us your questions and give us our likes and subscribes. Thank you for everybody who joined us today. This was 11th episode of DevOps Accents and your hosts, Leo, Kirill, and Pablo.
The cloud tech industry is evolving so fast. Do you keep up with it by improving your skills or upskilling your team? At MKDev, we offer a variety of workshops for just that, from the basics to expert knowledge. Before delivering our workshops and training sessions, we carry out a detailed assessment of each participant. To make sure the workshop is helpful for you and your team, we will add more content to it or throw out what you already know. Or we create a custom workshop specifically for the needs of your team and the specifics of your project.